Welcome to the Shearwalls online tutorial videos. This third video out of 4 will further detail the rigid diaphragm design and demonstrate how to use this function in the software. We have earlier described the differences between the two diaphragm distribution methods and then discussed the flexible distribution assumption in the previous 2 videos. We will now turn our attention to distributing forces assuming a rigid diaphragm. This was already covered in the previous flexible design training video, but we will highlight it here again. The CSA 086 commentary and the American Society of Civil Engineers 716 provide guidance for when a diaphragm may be idealized as flexible. The equation shown here indicates that if the maximum diaphragm deflection is greater than 2 times the average shear wall story drift, then the diaphragm can be idealized as flexible. Following CSA Commentary Clause 11.5, diaphragms shall be idealized as rigid when the maximum deflection is less than half the average story drift. This criteria can occur in mid-rise light frame wood structures. The Shearwalls software does not calculate diaphragm deflection at this time, so you would need to compare the shearwall deflection results from the software with diaphragm deflection results calculated separately. This is the same existing model used in previous tutorials, where only a flexible analysis was completed. The link to the downloadable file for this simple building is provided in the description below. Now, should we only want to complete a rigid analysis, we would uncheck the flexible diaphragm analysis feature available in the structure block input view, just like in previous videos. We can now generate the loads and run the design based on a rigid diaphragm analysis. Note that when we disable the flexible diaphragm analysis feature, no design information will be generated regarding it. Now we know that the forces distributed depends on the rigidity or stiffness of each shear wall. When rigid analysis is toggled, after the design is run, the log file will become populated with torsional analysis details for wind and seismic loads for each direction of the structure and each story. We will further discuss these details in the next video.